In this video, I'll talk about feature transforms. I'll briefly remind you that the hypothesis sets of the three algorithms we've seen. The hypothesis set of the perceptron was hypothesis H of the form sine W transpose X. In linear regression, the hypothesis set was H of X, where H of X was just W transpose X. For logistic regression, the hypothesis set was hypothesis H of X, where H of X was equal to sigma, the sigma function of W transpose X, where sigma of something is the sigmoid function, which is 1 over 1 plus e to the minus s. This is the sigmoid function that looks like this. Oh, let's see if I can draw this. This is a bit difficult to draw. This function is in 0 and 1. In the logistic regression IPython notebook, there is a plot of this function if you want to see it. Great. So these seem a lot similar. And notice that the way our weights in each of these interact with the data, it's linear in all of them. It's kind of like this. It's the inner products, right? So in this case, our models are kind of linear. So this kind of becomes a problem if the data looks like this. You can think of these models trying to find lines. So there won't be a line separating this data set in a very good way. If we run the pocket algorithm, we'll see something like this, and we won't really get anything useful out of it. This is just, it won't really give anything good. So what we can do is, if we have data of this form, so imagine you have data and it looks like this, and then we could take each point of the data and we could apply a feature transform. So let's say each data is a point P, where P is equal to X and Y. So like these are the coordinates of the points. Then phi is the feature transform that takes such a point and it gives me X squared, Y squared. Then basically these points will all be the radius or the distance from the center. Like I'll get that all these points will be around here maybe, and these points would be further away. They would maybe live over here. And now I'd be able to use my linear models to separate the data in this features transformed space. So I have transformed the features of the data by squaring each coordinate. So the interesting thing is I could take this line now and I could apply, so this hyperplane, this line, I could apply the inverse transform and I would actually get a circle in the original space. So in this way I can kind of I could make I could add power to the linear models and make them do nonlinear things with circles. So this is, in Python, this is actually rather nice to write. You just write the data squared and you'll actually do this feature transform. And if we run the algorithm, it'll look something like this. So this is in the feature transformed space, this space. So what we could now do is I made this visualization where you do the inverse feature transform of the line and you'll see it in the original space, and then it'll be a circle. So this generalizes to other shapes. You just this depends on the feature transform. So this is a very nice trick. You get to do some very nice stuff. Okay, so this is what I wanted to say about feature transforms. I'll see you in the next video.